The third topic that we had in this category was partitioning. Now, one problem is, let's say you have your invoice table and this invoice table gets super big. This will then get, from the write perspective and also from the read perspective, it will get slower and slower and slower because the table will get really huge. So what you would do is you would actually try to index this, try to partition this based on something. So that you say, okay, for instance, here our invoice number is our partition key here. And you would, could for instance say, okay, either these invoices are generated more at a random number, or that you add some prefix to it. So the one gets added with the A XX, the next one BXX, CXX, and then you could go and could basically add your own partitioning in this, or your own method of that's the wrong explanation. Like, then you would have these numbers that you could easily partition to, where you say, okay, I'm creating 10 partitions here, and I'm partitioning it by the A minus B minus C, or just the D. And this way you could basically distribute it very easy, your data across partitions, because the invoice gets generated randomly one of these partitions, and then it will actually go there.
Is there a case where it would matter whether how you partition it, like you decide what goes to A, B, or C, or randomly is?
It depends a bit on your use case. If you can do that, of course, it makes it a bit more difficult to always, when you say, okay, you have your customer. Let's say this usually would be partitioned by the customer ID. Then everything from the customer would be in one partition. So if you query something from the customer, the database only needs to look in that partition. The other way around, then this is slower for the write, because everything always goes to one partition. Now, for this example, it's not that terrible, because these are how many sales can you make a second, or how many purchases. But it's a problem. The other way is if you distribute it, then the database has to look for it in multiple partitions. So it's always a bit of a trade-off. So it would most likely be a bit slower for read, but a bit faster for write, because it will dump it in multiple partitions. And you could say these partitions are on different drives, for instance. Where this is very important is whenever you work with time series data, because time series data, naturally, the data is written by the time, and the time is incrementing. And what would happen if you partition this by the time column, everything would go just into your, let's say, now partition, where all the new data is. And then at some point this would maybe get split, and then you would have some historic data partitions. But everything new that comes in would flow into this. So this would actually prevent your system from using all the capacity or all the performance that it has, because that's what's called hotspotting, because you're hotspotting on one of these partitions. You see this in relational database. This is also something that you see in NoSQL databases very often. That you could say, okay, instead of sending the partitions to different drives, you're sending this to different servers. But it doesn't use the other servers, because everything flows to a single partition to a single server, and you wonder why it's so slow.